All right. Um, let's take a look real quickly at this one because there seemed to be confusion on this also. Now look, gravity is perpendicular to the distance. This guy's doing work, but gravity, no. Now, friction is doing work. And if it's moving, it's actually called, we call it the coefficient of kinetic friction. And that's moving this way, okay? And so that's doing negative work, whereas this is doing positive work, all right? But gravity is perpendicular to the whole thing, so it would be C. All right. So anyway, I think, okay, so let's just kind of talk through problem 12 here real quick. And it says a stationary 0.175 hockey puck is hit with a 200 Newton force and pushed 0.25 meters. That's a force times a distance. What was the work done on the puck? Force here times distance. Okay, so that's pretty straightforward. What are the proper units for mechanical work? Well, again, it's one of these guys. Okay, and then question 14, and that's where we're going to that's what we're going to try and answer here quickly, because I don't want these things should stay around 2 to 3 minutes, and I'm kind of windy anyway. So calculate the speed of the puck after it pushes, after the stick after it is pushed 0.25 meters. Okay, and we're going to find its speed in meters per second. And in fact, we're just going to make this I'll say this will be problems 11 and 14 that we looked at. Okay, so let's take a peek here. So we know from problem 12 that the work done is equal to force times distance, right? So we know that, and that came out to be I think 50 joules of work. Because 200 times 0.25, 1/4 of 200, basically comes out to 50 joules of work. Okay, so what we do is now we know that it's moving, and I think I took the and that's a big concept that I just kind of assumed. Oh, y'all know that, or I told you once, you should know that. Well, with my 210 students, I beat it. This is 6 weeks down the road, 7 weeks down the road in the course that we're talking about. This not week 2 in a 100 level course. So that's ridiculous. That's kind of, I forget myself sometimes. So we've got this. So is equal to 1/2 mv squared. Okay. All right. So because this is the kinetic energy, the final kinetic energy of it when it gets going. And then eventually it'll slow down as the friction of the ice works on it and slows it down. Okay. But anyway, so we've got this. Now we know the mass of the puck is equal to 0.175 kilograms. And this is actually problem 14. Okay, and so and this is equal to 50. So let me just set it up this way: 1/2 mv squared is equal to 50. So we multiply both sides by 2. We get mv squared is equal to 100, and then m I think was 0.175. And for some, and then I also realized for some of you, these calculations are something you haven't done since 8th grade or 10th grade. And you're going, wait a minute, what? You're killing me. All right, so we wind up with, so we'll divide both sides by m. And we get v squared is equal to 100 divided by 0.175. Now that's not your answer. You got to take the square root of that. So you have your answer, then hit your little square root button, or if your calculator's like mine, you can do it all in one step, like this, and it will equal, so we'll clear all that, will equal the square root of 100 divided by 0.175. We'll close that parentheses, boom. Yep, 23.9. I think I had the answer in there. It's V. It's 23.9 meters per second. Now you're given the answer, you can go ahead and put it in, but go ahead and work it out. Just write it out, and then see if you can do it. Set it up. It's going, okay, well the force times is 50 equals 1/2 mv squared, and just try and work that algebra out yourself. All right. So before we go on to 15 and 16, let's go ahead and stop this movie.